Hello, greetings, and warm welcome. You're now entering the Valves Industry Flash Learning Series, a powerful set of 100 industry-specific communication flashcards designed to sharpen your technical vocabulary, workplace communication, and real-world usage across operations, sales, engineering, and maintenance teams. Each card includes a key phrase commonly used in the valves industry, a simple definition to clarify its meaning, a sample sentence showing how the phrase is applied in a real-world context, now expanded into detailed voice-over-friendly narration for each. Let's begin with cards 1 to 25. 1. Flow control valve. A flow control valve is used to regulate the rate of fluid flow in a pipeline. It's crucial in process industries where too much or too little flow can affect product quality, equipment safety, or operational efficiency. For instance, we've installed a new flow control valve to manage the cooling water more precisely, ensuring consistent temperature control in the heat exchanger. 2. Pressure drop monitoring. Pressure drop monitoring is the process of tracking pressure changes across a valve or pipeline section. It helps identify clogs, blockages, or wear in the system. For example, regular pressure drop monitoring helps us detect clogging early, allowing maintenance before it impacts production. 3. Actuator calibration. Actuator calibration ensures that the valve actuator responds correctly to control signals and moves the valve to the right position. Without proper calibration, the valve may under or overperform. The maintenance team completed actuator calibration before restarting the system to ensure precise modulation during startup. 4. Valve stem alignment. Valve stem alignment refers to ensuring the vertical shaft that connects to the actuator is properly aligned within the valve body. Misalignment can lead to friction, seal wear, or mechanical failure. Stem misalignment was causing premature wear on the sealing surface, so we corrected it during the service interval. 5. Seat leakage test. A seat leakage test checks whether the valve can fully block flow when in the closed position. It's a standard part of quality assurance for tight shutoff valves. The seat leakage test confirmed the valve is within Class 4 tolerance, which is essential for our zero leakage application. 6. Manual override feature. A manual override feature allows an operator to manually operate a valve in case the actuator fails or power is lost. This is important for emergency or fail-safe operations. The manual override feature was used during the power outage to shut off the steam supply manually. 7. Quarter-turn valve. Quarter-turn valves, such as ball or butterfly valves, operate with just a 90-degree turn of the handle or actuator. They are known for their fast operation and are often used in on-off applications. A quarter-turn valve was chosen for its quick shut-off capability in the chemical dosing line. 8. Control valve tuning. Control valve tuning involves adjusting the control settings to ensure the valve responds accurately and smoothly to changes in process conditions. We're fine-tuning the control valve to eliminate process fluctuations and reduce system oscillation. 9. Pneumatic actuator. A pneumatic actuator uses compressed air to move the valve. It's favored in explosive or hazardous environments due to its safety and reliability. The pneumatic actuator responded well to the emergency shutdown signal, closing the valve in under 2 seconds. 10. Valve positioner. A valve positioner ensures the valve opens to the exact position commanded by the controller. It compensates for friction and pressure to provide accurate control. The positioner helps maintain stable flow despite pressure changes in the pipeline. 11. Bonnet leakage report. A bonnet leakage report documents any fluid or gas leakage from the bonnet, the upper part of the valve enclosing the stem. It's a key inspection checkpoint. A bonnet leakage report was filed after the steam valve inspection and led to immediate gasket replacement. 12. Valve tagging procedure. Valve tagging involves assigning identification tags to valves for traceability, maintenance scheduling, and safety procedures. Please follow the valve tagging procedure during installation so we can quickly identify units for testing. 13. ANSI class rating. The ANSI class rating denotes the pressure temperature capacity of a valve as defined by American National Standards Institute. It ensures the valve matches system requirements. The selected valve meets ANSI Class 300 requirements, making it suitable for high-pressure steam service. 14. Globe valve configuration. A globe valve uses linear motion to control flow, making it ideal for throttling applications. The internal disc moves perpendicular to the seat. We use a globe valve configuration for accurate flow regulation in the fuel mixing chamber. 15. Torque requirement specification. This defines how much torque is needed to operate the valve under pressure. Ensuring correct torque helps prevent stem damage or failure. Make sure the actuator meets the torque requirement specification before starting the installation. 16. Fail-safe valve mode. Fail-safe modes define the default valve position in case of actuator or power failure, like fail-open or fail-close. It's critical for safety systems. This model has a fail-close, fail-safe valve mode for safety during loss of power. 17. Pressure seal bonnet. A pressure seal bonnet tightens its seal as internal pressure increases, commonly used in high-pressure, high-temperature systems. A pressure seal bonnet was recommended for the superheated steam line in the power plant. 18. Valve seat resurfacing. Resurfacing the valve seat restores its sealing surface, extending the valve's life without replacing the entire unit. We scheduled valve seat resurfacing during the shutdown to improve shutoff performance. 19. Deadband analysis. Deadband refers to the range in which input signal changes don't move the valve. Analyzing deadband helps optimize control system responsiveness. Deadband analysis helped reduce loop oscillations in the reboiler pressure control system. 20. Multi-turn valve. Multi-turn valves, like gate and globe valves, require multiple revolutions of the hand wheel or actuator to open or close. They offer fine flow control. Multi-turn valves are preferred where gradual flow control is required, such as in cooling water regulation. 21. Differential pressure reading. This measures the pressure difference between valve inlet and outlet, often used to detect blockages or flow resistance. We recorded a differential pressure reading of 4 bar across the trim, indicating buildup. 22. Packing gland adjustment. Tightening the packing gland ensures a leak-free stem seal. It's a routine maintenance task. A quick packing gland adjustment resolved the stem leak and improved sealing integrity. 23. Flow coefficient, CV. The flow coefficient represents how much fluid a valve can pass at a given pressure drop. It helps in sizing and selection. The flow coefficient, CV, was recalculated for the new application to ensure optimal valve sizing. 24. Cryogenic valve application. Cryogenic valves are designed to function reliably at extremely low temperatures, often using special materials. The cryogenic valve application required special stainless steel trim and an extended bonnet. 25. Smart valve diagnostics. These diagnostics offer real-time insights on valve health, position, travel time, and failure warnings. We enabled smart valve diagnostics to catch early failure signs and schedule predictive maintenance.